it's a process consists of several steps. So we call it sampling. When you take a sample, as you can see at the bottom of this slide, several 5 samples, but none of these samples is as good as the one I chosen here in the graph. Because if you take a look at this one at the far left, that actually misses a lot of stuff in the population. So it really, this sample represents a different population, not this population. Those are samples, but this one is the only one that represents this population. So whenever you are studying a population, you have to take a sample that represents that population. Otherwise, you're not studying the population. Can you imagine studying the population of Al Faisal and only studying guys and males? See, okay, that's enough. I can get a larger sample. Instead of 10 males, I can get you 300 males. Even if you get all the males at Al Faisal, it's not a representative sample. It's not about how large the sample is. It's about how representative it is. Then you talk about size. Okay? Now, a review. So what we've done in this course so far, we talked first about numerical summary measure. You have a data set like Dr. Fuad is showing you in the lab, and then you need to analyze it. You need to examine it. You need to diagnose it. If I want to speak your language, you want to diagnose the data. This data has some information. Your job as a physician is to discover this information. Now, you are trained to do this. Why? Because when a patient comes to you with a disease, your job is to discover the disease and find out how to treat it. That's exactly what you do with the data. But instead of one patient, we're talking about 100, 200, 300, 1,000, you name it. So instead of one patient, we're talking about sample of patients. It can be small, it can be large. So first we said, let us first get to know the data. What is the center of the data? How variable the data is. Then we talked about the probability, how the data is distributed. Is it symmetric? Is it not symmetric? If you have outliers, the data is not symmetric because one tail will be stretched because we have an outlier. And then we say, okay, let us estimate the mean and estimate either point interval, which is the mean, or confidence interval, as you've done before. So you have a confidence interval. All of those called estimation. Then we talked about hypothesis testing. If I am doing the study, I'm making a hypothesis that, for example, in my previous example, I have vitamin D and the infection with the virus. Well, my hypothesis can be the higher level of vitamin, the less you are susceptible to infection, meaning vitamin D is protective. That's my hypothesis. Where do I get the hypothesis? I got it from previous studies, from my experience. So in the study, I need to test the hypothesis. So the difference between hypothesis and other things is that the hypothesis is something that you can test, which means at the end of the study will tell you whether your hypothesis is right or wrong. If it tells you your hypothesis is right, meaning yes, the vitamin D is protective. If wrong, no, it is not. So that's what the hypothesis. So you need to test the hypothesis. And Dr. Peter gave you steps to test one type of hypothesis. Today, I'll give you another type of hypothesis. And then he talked about t-test and other tests. Any questions? All right, so now today, we are going to talk about the relationship between two variables, okay? Now, the correlation analysis, I'm going to make a little bit of introduction. Researchers used this method to measure the strength of relationship between two variables. So you can actually, notice from your data or from your daily experience that two variables are related to each other. But you cannot measure and quantify this relationship unless you have a statistical procedure. For example, what is the relationship between height and weight? Well, somebody tell me, of course, if the height, if the height increases, the weight definitely is going to increase. So we know that there is a relationship. But can you quantify it? Can you give me, if I increase by that certain amount, how much the weight will be increased? That when we need correlation analysis. Now, remember, I'm going to say it now and at the end of this lecture, correlation does not mean causation. If anything you want to remember from this course is that when I say two variables are correlated, it doesn't mean one causes the other. We, using correlation analysis, our job is not to find which variable causes the other variable. All what we need to know if they vary together, meaning if one increase, the other decrease, or if one increase, the other increase. So either it is positive, meaning they increase together and decrease together, or it's negative, one go one direction, the other go the other direction. And then to measure the strength of that relationship. Now, remember from previous lecture, we talked about continuous variables and talked about other type of variables. Mute your computer.
Doctor, can I ask a question?
Oh, okay. Okay, don't mute your computer then, please. Okay, go ahead.
Why we cannot call it cause and effect? What's their correlation?
Good.
I didn't get that.
Good question. Let me explain it to you. I will explain it again and again and again until you feel satisfied. But for now, let me give you a simple example. If I tell you that there is a relationship between the color of the car and how many tickets the driver will get. I mean, they found out that if you have a red car, you're more likely to get a ticket because the police people do not like red cars. Okay, so okay, there is a relationship. If I found out that there is a relationship between red cars and tickets, is that a cause and effect? Of course not. You see, or if I counted what is the color of your car down there in the parking lot and your grade in statistics, you might find there is a relationship between them, but this relationship is not causative relationship. The color of that car does not cause that. Now, some relationships are causative, but not all relationships. Meaning, when I'm using correlation analysis, I'm not looking for causation. Okay, where do you look for causation? If you want to look for causation, you use clinical trials. Clinical trials is really another statistical and biomedical system that can help you find which variable causes the other variable. Is that okay? Is it clear? Yes or no?
She's saying okay in the chat.
Okay. I don't see the chat, so please chat with me, or if they chat, please let me know. I don't see the chat in front of me because I have too many things here. Anyway, so remember, if you have continuous variables, you use correlation analysis. If you have categorical variable, you use the chi-square, which will be talked about when we talk about the categorical variables and talk about parametric and non-parametric, which is next lecture. I will elaborate on this. But this is now a statement. Okay. Now, from your background in high school, you studied the line, okay? You studied the line and you know how to draw a line. You have X and Y, and you know, for example, this, you see this line, so you know how to draw a line. That's how they told you about the linear relationship or the linear equation. So that you have in linear algebra in school. So the most basic relationship between two variables is that they vary. When they vary, they draw a line. For example, these two variables, we have the Celsius and Fahrenheit. When they vary, they draw a line. So their variation is linear. Okay? So that now other variables can be not nonlinear. Let me show you another relationship that is not nonlinear. Sorry about this. This relationship, look, these two are two variables. They don't vary they don't draw a line. They draw a curve. So they are related. However, the relationship is not linear, meaning when they vary, they don't draw a line. Okay, sorry. Close your eyes. I'm going to go back upstairs. Okay. So this is now, and again, I am reviewing high school material, so please read it at home and enjoy it. If you have any question, come back, but it's very simple. And this is the linear equation as you know it, y equal a plus bx, and they told you also that b is the slope of the line, and then a is where the association line crosses the y-axis, okay? So that's, excuse me just 1 second. So that's the equation. And if you solve this equation, you get a line similar to this line. When you get this equation, you get a line like that. So the equation that helps you draw this line is this kind of equation. Now, in statistics, why we call it as a, do we call it independent or dependent? We call it dependent variable. Why? Because y depends on a, depends on b, depends on x. However, x, we call it independent because x does not depend on y. X is like age. Age will change no matter what. But weight will change with age. The older the people most of the time, not all the time, the older they are, the weight have the tendency to increase. So age is independent, doesn't have anything to do with weight. Age is age, but weight, it is dependent on, in this case, on age. So that again, this is really how do we interpret that. So now, for example, converting temperature to Fahrenheit. So this is the equation. Fahrenheit equal 32, which is the freezing point, plus 9/5 times the Celsius. So if you have a degree in Celsius, you plug it in this equation and get how much it's equivalent in Fahrenheit. You know that Fahrenheit is a British system where it is used in the United States, it's used in the kingdom, United Kingdom. Celsius is in the Middle East and Europe. So if you want to convert between these two, you use the linear equation, okay? And we call these two variables, the Fahrenheit and Celsius, we call them the variable that are linearly correlated, okay? So one way of demonstrating the relationship between two variables is to use this line, to use this graph. So graphically, you can show the relationship between two variables, okay? We call it scatter plots. And I think in the lab you have covered that. If not, inshallah, I will ask Dr. Fuad to cover it. I think you'll cover it. And two-way meaning X and Y. It's one way, this is Celsius X and Fahrenheit Y. So that's why we call it two-way scatter plot, okay? Because there are 3 ways, 4 ways, different, but that's really not in our class today. Suppose we are interested in a pair of continuous variables. I have 2 variables, X and Y, and like before, X is Celsius, Y is Fahrenheit, and then each is measured on the same set of patients or same set of the different countries. So this is an example now. You can read this example. To study the relationship between the following variable, X and Y. For example, if I say X, just for illustration, the percent of children who have been immunized against an infectious disease like the disease we have, but in this case, against tetanus. So Y is the mortality rate. You know from your medical background that the vaccination prevent death. It may not prevent it 100%, but it is almost perfect sometimes. Sometimes it is not. So this is a relationship. The question is it really linear relationship? So, and this is background. I'm just telling you what tetanus is, and I'm sure you know what tetanus is for those who are not familiar with it. So what is an epidemiologic fact? The under 5 mortality rate, what we call it the Y variable, mortality rate. The under 5 mortality rate is considered by some as the most important indicator of the level of well-being of a population. In this course, we study epidemiology and biostatistics. In epidemiology, you study the well-being of populations like the Saudi population. One of the ways to measure that well-being is to have the under 5 years mortality rate. Okay, so for example, we got you a data about 20 countries, and this is the data. Look at this data. I'm sorry, it's a little bit. Now, this is the data. The left column is the nation, Bolivia till United Kingdom. The variable X, this is the middle variable, is children immunized by age 1 year. Okay, so what is the percent of children in this country that were immunized by age 1? And then this is under mortality rate per 1,000 live birth. So instead of saying how many dead, we say dead per or mortality per 1,000, and then you multiply by how many thousand you have in this population. So look at this table and tell me, do you think there is a relationship between immunization and mortality rate? Just look at the numbers, look how they vary. Remember, those are two variables. Why variable? Because for each country, I have two different numbers. Change the country, the number will change. So those are variables. So variable X and variable Y, are they correlated or related or associated?
Doctor, there's a mix of answers in the chat. Some people are saying yes, and some people are saying no.
Okay, for those who said yes, can somebody please speak up? You are true, but speak up, please. Tell me, why do you think it's yes?
And guys, you can unmute yourself and give your answer.
Doctor? Yes, I agree. It is yes.
Yeah, but how did you, you are absolutely right. How did you come up with this conclusion?
Most of the countries, when you decrease the percentage of children immunized, the under 5 mortality rate increase.
Fantastic, thank you. Now you have a quantitative mentality. Now you have a quantitative ability. This is how I want the physicians at Al Faisal to be. They are excellent super clinicians, and at the same time, they are quantitatively able, quantitatively ready, quantitatively prepared. So that's exactly right. But did you see how it's uncomfortable to sit down and stare at this table and find out the relationship? Later on, I'll give you a simple equation that will show you the relationship in a very simple way. So you're absolutely right. If you, for example, look at the 90, if we have higher percentage, look at the mortality rate, and look at the 13. Usually, in this case, I advise you to look at the extreme, and that will tell you. If you have so high of an immunization, you get so low of mortality. If you have the lowest mortality, which is 13, the lowest immunization rate, which is 13, look at the mortality. So yeah, there is some kind of relationship between them. When one increase, the other decrease. We call it negative relationship, meaning when one go one direction, the other go the other direction. Positive relationship, if they go the same direction. If one increase, the other increase. If one decrease, the other decrease. Okay, thank you. Okay, so this is scatter plot, and then this is an example. You can read the example, actually explain it. Now, instead of a table, look, if we substitute a table with a graph, this is the same relationship.
Apologies, doctor. Apologies, doctor. There's a question in the chat about, I think, the previous slide.
Go ahead.
It's Ala asking why here we can't say that it's cause and effect.
Why am I saying it's causative?
No, why over here we cannot say that it's cause and effect?
Okay, this is an excellent question. Look, because of the limitation of the statistical method. The statistical method tells you that they are correlated, but it cannot detect if they are causative or not. They might be, remember, they might be, but you need some other way, okay? Now, let me give you an example. Let's say that we say that, yes, it is causative. And it turned out, no, it turned out that in these countries where they have lower immunization, it's not about immunization. They have war and people are dying. And it's actually true. In Africa, most of these countries, they have war and people are dying. So it's not because of the immunization, it's because of the war. So we really don't know. Is that clear? Yes or no?
She's saying yes.
I'm sorry?
Yes.
Okay, good. Yeah, speak up, don't worry about it. So we cannot make a judgment about causation unless we study very, very thoroughly the situation. Okay, so in this graph, do you see the relationship? Is it really, does it confirm the table that the relationship is negative? Meaning when one increase, the other decrease?
We actually have two answers in the chat. One is yes and one is no.
One is no, okay. So the one is no, I need to talk to you. Please, can you talk to me, please?
Iman Ijaz, can you talk with the doctor? If you could unmute yourself.
If you don't want to, that's fine. I mean, just say no, I don't want to talk to you. It's okay. I'm not going to cry. It's okay. I'm a big boy. But if you want to talk to
Hi,
me,
doctor.
talk.
No, it's fine. I don't mind.
All right, good. Look, why do you think there is no relationship?
There is in the beginning, but if you I was looking at the majority, it doesn't seem to be any, I mean, to me at least, it doesn't seem to be, but there's no pattern. It's just scattered randomly.
Okay, let me just lead you through the pattern. Will you please? Look at this dot here. Do you see that?
Yeah.
If you go down the line, what do you think this will draw? I'm sorry.
So we're not looking at majority of the points. We're only looking at the general pattern that we can.
About the trend. Forget about the majority. I'm talking about the trend. What is the general trend? The general trend. Yes. You see what I'm talking? Look, in this situation, there is no exactness. It's just a trend. You know what the trend is?
Yeah. That makes sense.
One increase, the other tend to decrease. Sometimes not all of them, but the majority tend to decrease. And if you look at it, really, it goes down from the corner to the corner. You can actually draw a negative line here. See what I'm talking about? Great. So,
thank you.
But can you see now it's better than this ugly table? This really, you have to stare at it for a long time. This one, I can draw an imaginative line like that, and it is a negative relationship. When one increase, the other decrease. Good, thank you. So again, this is exercise for you to do at home. Those are examples for the exam. I use them for the final exam. I give you the exercise, give you the solution. I want you to work at not just attend and turn on the computer. This is you need to work at home. Now, another relationship, birth weight and increase in the weight between 70 and 100 days. They found out that the increase in weight for kids, between 100 and 100 days is extremely important for the growth. It's a good characteristic. It's an indicative characteristic, a characteristic that they use to study the health of kids. Now, they found a relationship between birth weight at the time of birth, and then if there is any increase in weight between 70 and 100. 70 and 100 days of life. Look at the table and tell me if there is a relationship between these two variables. X and Y. X birth weight, Y increase in weight. So the answer is yes. There is a negative relationship, the same thing. Look at the line now. You see, I plotted the data and look at the data. It's perfectly negative. When one increase, the other decrease. So to find out if there is a relationship between two variables, we can use this method, which call it the scatter plots. Class exercise, also use it. This is another exercise. Now, we don't want to do scatter plot because it's not really an exact method. It doesn't tell you how strong the relationship is. Just give you a graph. Well, luckily, there is a method in statistics called correlation analysis that can measure the correlation between two variables and then So first, it tests the correlation. We use something called correlation coefficient. It tells you whether the relationship is positive or negative and how strong the relationship is. Is it strong, weak, or there is no relationship? And also, we then, after we get the relationship, we have to test, is it significant or not, meaning statistically significant, as you did in the course with Dr. Peter. Now, again, then we establish the cause and effect. Then we can say, wait a minute, this is not a causation. How do you establish causation? Then we can go to the next step and say, finally, after you do that, you have to go to the next step and establish causation using other methods. So the correlation, what is the correlation coefficient? So it measures the extent to which two variables tend to change together. If two variables change together at the same time, in a linear fashion, this coefficient can measure that relationship. It measures two things. Please remember the strength and direction. It tells you if the change in the same direction is strong or weak. And also it tells you, is it in the same direction or opposite directions? Okay, we have two coefficients. Remember how many types of data we have? We have nominal, ordinal, continuous, discrete, all kind of this kind of data. Now, for each type of data, there is a statistical procedure. You cannot use the same statistical procedure for all types of data. If you use continuous data, we use Pearson correlation coefficient. If you use ordinal data or data that have outliers, or the data is not normally distributed or skewed, as we say, we use something called Spearman correlation coefficient. Both are exactly the same. They have similar equations. Everything is the same about them, except when you use it for data that is normally distributed and continuous data, one data that is ordinal. Okay, so this is the variation between the two. Okay, so this is now the correlation coefficient. I'll leave you to read it now. Now we're talking about Pearson correlation coefficient. We call it R, little r. You see it right here, little r. Pearson correlation coefficient, R. Now the other one, we call it RS from Spearman, but this is R by itself because this is the original one. What are the properties of this coefficient? First, it has no unit. The correlation has no unit, gram or meter, no unit at all. It's just number. And R is between -1 and +1. Remember, don't mix it with the probability. The probability is between 0 and 1, remember? So I will give you a question in the final exam, and some of you is going to make a mistake. R cannot be more than 1 or less than -1. This is the interval between -1 and 1. If you have -1, you have exact linear correlation. If you have +1, it's exact positive linear correlation. So one negative and one positive. Exact meaning all the points are on the line. Okay? So also this is also explain what I said before, but I tend to give more explanation in the lecture to help you in case you don't understand what I'm saying. Look at this table and see how wonderful this table is. Now, after this table, you are going to learn everything you need to know about the direction and the strength of a linear relationship. First, so this is now, remember, this is Pearson correlation coefficient. I have two characteristics, the strength and the direction. Remember, the direction can be negative or positive or no relationship. No relationship means it doesn't matter. If one goes one way, the other goes, it may not change at all. So there is negative direction and positive direction. What is positive direction? Both of them go up at the same time or go down at the same time. Negative, one go up, the other goes down. Now, if I have the strength, how do I quantify the strength? Strong relationship is between, now remember before, what are the limits of R? -1 to +1. So if it is -1 to -0.8, it's negative, but it is strong. -7.7 to -0.4, negative but moderate. 0 to 0.3 or -0.3, weak. So remember, anything between 0 to 0.3 is weak. 0.4 to 0.7 is moderate. 0.8 to 100 is strong. Now you can add to it positive and negative. So if I tell you the relationship is 0.6. What is it? 0.6, you say, oh, wait a minute, 0.6, it meaning not negative, it's positive. And 0.6 is between 0.4 and 0.7, it is moderate. So it's moderate positive. Is that clear? Is the table clear?
Yes, doctor, they're saying yes. Doctor, just saying something that sometimes the students, they're typing in the chat, so they take a while to appear. So it might take longer.
Stop me, please. Yes, stop me. Tell them, look, instead of typing, just say, I have a question, or type Q, then we can stop.
Sure.
Don't wait until you type the whole question. Be efficient, type Q, and then we'll stop.
Sure.
Okay. So now this is the equation. How do you calculate the coefficient? It's a very nasty equation. Do I want you to memorize it? No, you don't have to memorize it. Do you have to worry about it? No, but I'm going to tell you how to use it, because in the lab, Dr. Fuad is going to show you how to calculate these coefficients, whether Pearson or Spearman, using the software. So you don't have to worry about that. But let me show you how do we calculate that using the equation. Remember, what is the equation? The equation is, it's on the numerator, it says, that is summation, it's the sum, sorry. This is the sum. So you sum x, they have x variable and y variable. Each variable minus its mean. So you take each x variable and subtract it from the mean. So first you have to calculate the mean and take the difference between every x and the mean, and then every y and the mean, and then take the difference and then multiply them. Okay, and then you sum the whole thing. In the denominator, you sum what? You take x minus x bar and you square it. So the difference will be squared, and here the difference will be squared. You multiply this summation and you're done. And let me show you how we do it. These are x and y. I have two variables, x and y. X is 1, 2, 3, 4, 5. Y is 3, 6, 9, 12, and 15. The question is calculate the coefficient. Look at the equation down there here. What is the equation? Sum x minus x bar. This is x minus x bar. You see, you take xy minus x bar, which is, so let me go to the next one. I calculated x bar here, which is 3. So you take 1 minus 3, 2 minus 3, 3 minus, like this. So that's the first term, x minus x bar. Every x minus x bar. Every x here minus x bar, which is the mean. So you subtract this point from the mean, and that's the difference. You see the difference is minus 2, minus 1, 0, 1, 2. Those are my values. Do the same thing for y. For this one, take the difference and multiply it. So minus 2 multiply minus 2 by minus 6. Minus 1 by minus 3, and you get that. And underneath it, you sum all of these variables. You do that for x bar, and you do that for y bar again. So you do that for this, you do that for this, and then you sum all of it. And what is the equation? It's the summation of those divided by this. If you look at it, this is the numerator and this is the denominator. You divide them by itself and the answer is 1. So it becomes 30 divided by 30, the answer is 1. Because when you multiply 10 by 90, it's 900, the square root is 30. Please do that at home, and you see it's very simple, very straightforward process. Now, if I want to get, I may bring this table in the exam. You need to know how to do it. In the exam, I'll bring you similar table if I want to do that. I'm not sure yet. But most of the time, ask the student, every year we have a table like that, and you have to calculate the correlation coefficient. Okay, and it is very, very simple, and I did it step by step. So we do the summary now. You read the summary. Correlation now. Again, Pearson correlation coefficient measure two things. Remember, what are these two things? That's the strength and the direction. Is it weak, strong, or moderate? Is it negative or positive? And the relationship between, so it measured the relationship in two different aspects. Now, how do we do correlation research? Why do you need correlation in research? if you want to use correlations in the future, you are going to use it in the context of research. So let me show you how to do it. To research the relationship between two variables, you are doing a survey for your class, and you want to see the relationship between attendance and grade. Meaning, do you think that those students who attend all classes get higher grade? You want to test the relationship. Then you use correlation. Okay, what you do to run this research is to design a survey, ask the respondent questions related, collect the data, and after you collect the data, you run this coefficient using this table, and then you get the relationship. And then you can say the relationship between the two variables is high and positive, high and negative. So it's very simple process that you can do. Okay. Now remember, survey are quick and flexible. Most people do survey. However, what's the problem with survey? People may not be honest. Neither may tell you whatever. You're assuming every answer is right. No, wrong. Every answer is not right because people may lie to you. Especially if you ask them, do you like the dean of the College of Medicine? Guess how many will tell you no? See, so you don't want to overestimate the survey. Sometimes the question in the survey, or do you drink at Al Faisal, or you do smoke at Al Faisal? Like, what are you asking me? Are you crazy? Nobody is going to answer these questions. So don't rely too much on surveys. You have to watch for the honesty of the answers. An example. You plan to test the hypothesis that passive smoking causes asthma. Okay, so now this is my question. Now I can look. Remember, I'm saying here causes. Now this is really, I'm doing it in a clinical trial, but I'm using correlation. So correlation plus clinical trial, that's okay. But you cannot just run correlation and say it is cause. But in this case, all what I'm saying is I'm doing it within a clinical trial. So what is passive? You know what passive smoking is? I define passive smoking for you. When somebody smokes, passive smoking is the people who are inhaling the smoke rather than the guy. And the guy is smoking and somebody else inhaling the dirt out of, it's ugly things. Anyway, now, can you conduct a study about exposing children to passive smoking? Say, hey, I have a study. I want to expose children to passive smoking and see if there is a causation between them. How many one do you think will enroll their kids in the study? Zero, no one. They might shoot me also for that if I say that. So you cannot do the study. So it's not ethical. So how to test this hypothesis then? What do? You conduct a correlational study. You said, okay, what I'm going to do, I am going to find out if children, this is how you go around it. Look at children whose parents smoke. You go to the family, I say, divide the family between two families. One type of families, the parents smoke, the other parent does not smoke. And see how many of those kids in these families have asthma. And then you correlate them. So there are ways other than exposing children to passive smoking, and you have to be creative. So this is how we run the correlation in research. So I want you to get an idea about how to use it in research. Limitation, again, R is really only to talk about linear relationship. So let me show you this. Do you think there is a relationship between these two variables, X and Y? Yes. It's the relationship, if you start from left here, both of them, the relation, what happened is that they decrease up to a certain point and then increase. So there is a relationship between the two variables. Okay, this is a curvilinear, we call it curvilinear relationship, not linear. But if you test it with the correlation coefficient, it will be zero, because the correlation coefficient only sees, it's blind, it is blind to all other relationship other than the linear relationship. If you test any other relationship, it will tell you there is no relationship. But of course, you are not going to believe it, because this relationship, if you calculate the correlation coefficient, it will be closer to zero. Why? Because it's curvilinear, it doesn't see that. Okay, so there are some limitation for this, and also if you have outliers, remember the correlation coefficient, you have to calculate the mean, correct? Did you see the equation? You calculate the mean. Look at mean X bar down there. Mean is 3. So if you have an outlier here, the mean is wrong because it's inflated. You have an outlier. So the whole method here is not good. So you don't use this method. So what do you use? You use another method which we'll be talking about, call it Spearman correlation coefficient. Okay? So these are the limitation, plus the relationship you cannot extrapolate beyond the line. If you outside the line, you cannot tell, because look at this. I'm sorry about going. Don't look at this one. You can estimate the relationship at this point and at this point. You cannot just extend the line down there and say, I'm testing the relationship this area. No. You can only measure this area. That's the weakness of this measure. I'm sorry, I'm going to go back. Close your eyes. Sorry. Okay. So those are the limitation. And then again, it's not cause and effect. Please remember, it might be, but it doesn't tell you whether it's cause and effect. It might be. How do we know? We need another method, which sometimes referred to as clinical trial or physiological method or an anatomical method, investigative method rather than statistical methods. Okay? So now, what if I find out that I have outliers? What do? You cannot use Pearson. So you use another method called Spearman correlation coefficient. It's exactly the same thing. It is the same thing. It's the same information, the same characteristics, except for one single difference. In this correlation, you take the data and rank it first and run the correlation on the ranked data. Remember from previous lecture, when you rank the data, you don't have outliers anymore, correct? Because if you have 1 to 100, what is the rank? 1 to 3. 1 rank 1, 2 rank 2, and 100 rank 3. So the rank doesn't see the outlier. So when you rank the data, you remove the outliers. Then you use the same equation, but instead of using the actual data, you use the rank data. And inshallah, Fuad will show you that. So everything is the same. The only thing I want you to know is that Pearson rank, that's why we call it Pearson rank correlation. First, it's rank data, not the actual data. Second, you use it for ordinal data. You use it for data that is skewed, data that is not symmetric, data that not normal, data that have outliers. In this case, don't use Pearson. Okay? These are the same property as R. And again, remember that it's a good idea to examine the relationship between variables using scatter plot. And remember, this relationship is not linear, meaning that both correlation coefficient will give you 0 or closer to 0. It doesn't mean there is no relationship. It means there is no linear relationship. Remember that, please. Question: if R is what? Remember, R is Pearson correlation coefficient is 0.09. Which one do you think is the answer?
The majority of students in the chat, they're saying 2.
So it's strong and positive. Absolutely. Thank you. Great. Now I relax and know that you guys understood. There is no negative, which means it's positive relationship, and it's 89, which means 90. It's between 7 and 1. It is strong. So you see now, you didn't have to review anything. You didn't have to study even, and you know the answer. The same thing for this, and you can find the answer. This one now, this is a little bit tricky. So can you answer that? Do I have an answer, Dr. Suhaib?
Yeah, they're still coming in, but a majority of them are saying 4, positive correlation.
4. So you're absolutely right. You have passed this lecture, and I am so proud of this group. Really, really, you guys are smart and dedicated. I am so pleased, to have a group like you guys. So great. Now, testing hypothesis. Testing hypothesis is exactly the same way.
Excuse me, doctor. There's just a question. Iman Ijaz is asking, can we consider 0.5 as the cutoff point when options are just strong and weak relationships?
Can we consider what?
When options are just strong and weak relationship, can we consider 0.5 as a cutoff?
Strong
when
and
options?
weak? How can it be strong and weak?
Iman, could you clarify your question, please?
How can it be strong and weak at the same time?
I think
Like
what
it's
she's asking.
positive and negative.
I think what she's asking is if you don't have strong or weak in the specification in the choices, if they're just positive and negative. I think that's what she's asking.
Moderate. That would be moderate. You're absolutely right. That's why I said it's tricky. You're absolutely right. You're absolutely right. Because that's why I said it's tricky, because it can be moderate. You're right. So in this case, you can send me that, and in the exam, I will cancel this question. Thank you. Great. Please speak up, because most of the time, or all the time, you guys are right. So speak up, because it will benefit all of us. Thank you.
Doctor, can I have a question?
Sure, you can have several questions. Yes.
Doctor, if we only have two choices, strong and weak, what can we choose?
What can we what?
If we have only 1 and 3 choices, strong correlation and weak correlation, what can we choose?
Then if you have those, you have to see, is it closer to weak or closer to strong?
How can I know from this question? There is no number.
You guess. Exactly, you just guess. And let me tell you what, look, in this case, if you read the introduction, smoking lead to increased lung cancer, don't you think there is nobody in the world that they don't know that this is a very strong relationship, correct? And positive, because if you smoke more, you get more chances of being, having lung cancer. So that's what we rely on, is that this is an information that all of us know it is strong. In studies show that it is strong. Okay?
Okay, thank you so much.
Sometimes, no, my pleasure. Sometimes all what you can say that this question really it has more than one answer. And a lot of time we say, absolutely, you're correct, and we remove the question. I really like you in this you have to critique things. You don't have to be quiet. Critique things, because at the end of the day, this nature of critiquing is an excellent way if you do the critiquing in a very constructive way. And then you know what I mean. So let me finish this hypothesis testing. It's very similar to the other hypothesis.
Sorry, there are 2 more questions. Okay.
It's okay. Let me finish, please, because people have to go. I need to let them go. So the hypothesis testing, you know that it's very similar to what Dr. Peter did. And the main objective is to detect if the linear relationship exists. So there is a linear relationship, but is it really significant or not significant? I mean, statistically significant or not statistically significant? So what we do is we test hypotheses. So to determine whether 2 variables covary in a significant way, we use the t-test. We apply the t-test to the correlation coefficient, at a given n-2. So in this case, what you do, you have an n-2 degrees of freedom. So you apply the t-test to this correlation coefficient and remember in what Dr. Peter told you, it's n-1 in it, but here in this case, n-2. Why 2? Because remember, in this case, you know the mean and you know the variance. We included the mean and the variance in the equation. Go back to the equation, you see the mean and the variance, and that's why we have 2. And usually we have 90% or either 95 or 99%. Usually we use 99. So let's use this examples to do so this is the example. I calculated the R, and it turned out to be minus 0.79, which means it's strong negative, correct? Strong negative. And this is, if you have Pagano's book, if you can borrow it, it's calculated on 0.402. So you can do this calculation very easy. Then what do you do? So R is minus 79. So the question is this correlation significant? So what we do, we apply the same hypothesis testing. H naught, this, we call it ρ. This ρ is the correlation coefficient in the population. Because remember, in hypothesis testing, we test the value in the population, as Dr. Peter mentioned. So this is the correlation in the population is 0, meaning the two variables are not correlated. The alternative, no, it's not 0. It's not 0. So either can be positive or negative. It's not. What is the degree of freedom? N-2. So this is the equation. That's the t-test. That's the equation. And once you apply the equation, you go back and find out that it is the t is this, and what you find out at the end of the day that it is the less than 0.05, that, as we mentioned before, the correlation between the immunization and under 5 mortality is statistically significant at the 0.05 level of significance. Okay, and these are references. I know I rushed into the hypothesis, but please read it. I rushed into it because it is exactly the same application as you did for the t-test. So I'm not going to repeat again what Dr. Peter. So now you can leave now because I know you have another test. If you have a question, I'm here till 5.